In Lesson 2.4, we're going to be learning a little bit more about some linear equations and adding a few different types. We're still in our big idea number 2, function equations and graphs, and we'll be writing equations and graphing them. Our guiding questions: what do the slopes of two lines in the same plane indicate? They indicate the relationship between the two lines. The relationship between the lines. Do they intersect? Are they perpendicular? Are they parallel? Guiding question number 2. What are the forms of linear equations that we now know, and why is it important to know all these forms? Well, the ones that we know are direct variation, which is y equals kx. We know our slope-intercept, y equals mx plus b. And we're going to be learning 2 more. We're going to be learning our point slope, y minus y sub 1 equals m times x minus x sub 1. And we're going to be learning our standard, ax plus by equals c. So we're going to have four types. And why is it important to know all the forms? It's important because depending on the information that we're given for certain types of problems depends on the type or the form of linear equation that we'll use to help us answer whatever it is they ask of us. Our enduring skill will be our math practice standard number, and I forgot the number there, but it's look for and make use of structure. And how will we do that? You will find linear equations composed of a slope and a point of intersection and then determine its function. And you'll also use basic operations to change a linear equation into standard form. The point slope form that we saw that earlier when we answered our guiding question, gives us an equation using a point and a slope. And our formula is y minus y sub 1 equals m times x minus x sub 1, where the x sub 1 and your y sub 1 here come from our point. And if you look, it tells us here why it works. If you substitute the general point xy in for x sub 2 y sub 2 in your slope formula right here, you can rewrite it, and you see that when you rewrite it, it ends up being your point slope form. If we look at problem 1, it says writing an equation given a point and a slope. A line passes through the point -5, 2 with a slope of 3/5. So what is the equation of the line? So if we use our formula, y minus y sub 1 equals m times x minus x sub 1. We know our point here, our -5 is our x sub 1, our 2 is our y sub 1, and our slope is 3/5. So we just make our substitutions. In place of my y sub 1, I'll put 2 minus 2 equals my slope of 3/5 times x, and I'm going to have x minus -5, which if I look would be minus -5, actually is written x plus 5. So that would be our equation given a point and the slope. When would we need to use the point slope form of a linear equation? We would use the point slope form when we know a point and then the slope. And when would we use the slope-intercept form? We use that when we know the slope and the y-intercept, a specific point. So in problem 2 here, we're going to write an equation given 2 points. If I have 2 points, I can find the slope. So first, I want to find my slope. So I'm going to use my slope formula. y minus the y in the other one over the x's, 3 minus 5, gives me negative 6 divided by negative 2, which gives me 3. So m equals 3. Then I can use either one of these 2 points. It doesn't matter. I can use 3, 2, or I could use 5, 8. If I use 3, 2, I'm going to substitute into my point slope formula. Y minus 2 equals my slope of 3 times x minus 3. If I use the other point, I'm going to say y minus 8 equals 3 times x minus 5. And I'm sure you're saying, well, those are 2 different things. They may look differently, but if we solved both of those out to slope-intercept form, if we solved them for y, we'd see that they were exactly the same. So let's do that real quick. I've got y minus 2 equals 3x minus 9. And if I get my y by itself, I add the 2 to both sides, and I get y equals 3x minus 7. Over here on the other side, if I do my distributive property, I get 3x minus 15. And then if I add 8 to both sides, I get y equals 3x minus 7, which you can see they are the same. So even though in point slope form they look differently, when they are simplified to slope-intercept form, we can see that they're the same. Another form of the equation is what we call standard form. And in standard form, the sum of the x and y terms are set equal to a constant. When possible, you want to write the coefficients of x and y and the constant term as integers. That means if we have fractions, we need to get rid of them in these. And the formula says ax plus by equals c, where a, b, and c are real numbers and a and b are not both 0. One of them could be 0, but not both. If we look at problem 3 here, it asks us what the equation of the line y equals 3/4 x minus 5 is in standard form, and to use integer coefficients. So if I start here with my equation, y equals 3/4 x minus 5. I want to change it to standard form, so I need to get my x and y term on the same side. So I'm going to subtract the 3/4 x from both sides. And then I'm going to have negative 3/4 x plus y equals negative 5. And then I want to get my integer coefficients. So I need to get rid of that 4 in the denominator. So that means I would need to multiply my equation times 4. 4 times negative 3/4 x would be negative 3x. 4 times y is 4y. And 4 times negative 5 is negative 20. So then I would have an equation in standard form. X and y are on the same side, with a and b and c all being real numbers and a and b not both being 0. So to summarize, when we have slope-intercept form, y equals mx plus b, you want to use this form when you know the slope and the y-intercept. For point slope form, we want to use this form when we know the slope and a point, or when you know 2 points. And lastly, standard form. Standard form, a, b, and c are real numbers. A and b cannot be 0. And we use this when we need to find our x and y intercepts. That's the form that is easier to find our x and y intercepts from. We can graph an equation in standard form quickly by determining the x and the y intercepts and then drawing the line through them. If we look at the equation 3x plus 5y equals 15, we need to find its x and y intercepts. To find the y-intercept, you need to set x equal to 0. So if I put 0 into my equation, I have 5y equals 15, and I end up with y equals 3. So I have the y-intercept 0, 3, and I plot that point. To find the x-intercept, y is 0. So I have 3x equals 15, and I end up with x equals 5. So I would then have the point 5, 0, which I would then plot. And then I can draw a line through those points, and I have my line. Okay, let's do this guided problem. What are the intercepts of 2x minus 4y equals 8? So I have 2x minus 4y equals 8. So I want to find the x-intercept. So that means y equals 0. Whichever one I'm finding, the other variable is 0. So if y is 0, it's like that y term isn't even there. So my minus 4y would be 0. So I'd have 2x just as equal to 8, which gives me x equals 4. So I would have the x-intercept of 4, 0, because the y was 0. So now I'm going to graph it. 1, 2, 3, 4, 0 would be right there. Now my y-intercept, x is 0. So it would be like that term 2x is not even there. So I'd have negative 4y equals 8. Divide by negative 4, and I'd have y equals negative 2, which would be the y-intercept point of 0, negative 2. So I would plot that, 0, negative 2, which would be right here. And then I could draw my line through my two intercept points. Okay, our key concepts: parallel and perpendicular lines. The slopes of parallel lines are equal. That's an important piece of information. If I know that the slopes of two lines are equal, and I know the slope of one of them, I know the slope of the second one. The slopes of perpendicular lines are negative reciprocals of each other. So for example, if I had 3/4, its negative reciprocal would be, I take the reciprocal, which would be 4/3, and then I take its opposite sign. 3/4 was positive, so its negative reciprocal would be negative 4/3. So 3/4 and negative 4/3 are negative or opposite reciprocals of each other. If I had negative 7, negative 7 is actually negative 7 over 1. So if I took its reciprocal, it'd be 1 over 7. And then it would be positive because the negative 7 had been negative. So that would be its negative reciprocal. And you can always check yourself, because if you multiply negative reciprocals together, you get negative 1. So if you're not sure if you have the negative reciprocal, multiply them together, and if you get negative 1, you know you're right. Now we're going to look here at problem 6. We're going to write an equation of a line in slope-intercept form first that's parallel to y equals 6x minus 2 and goes through the point 1, negative 3. Well, first, if it's parallel, I know my slopes are equal. So that means this slope here of 6 means for the line I'm going to write, I'm going to have a slope of 6. And then I know a point. So this is going to be my x sub 1. This is going to be my y sub 1. Since I know a point and I know the slope, I want to write in point slope form first. So I'm going to write the equation in point slope form. Y minus negative 3 would make it y plus 3 equals my slope of 6 times x minus 1. Now they want me to write it in slope-intercept form. So then I would need to solve for y to get it on into slope-intercept form. So I do my distributive property. And then I would minus my 3 from both sides. And I have y equals 6x minus 9. So y equals 6x minus 2 and y equals 6x minus 9 are parallel because they have the same slope of 6 and different y-intercepts, negative 2 and negative 9. And now we'll find the equation of a line that's perpendicular to y equals negative 4x plus 2/3 and goes through the point 8,5. My slope here is negative 4, so its negative reciprocal would be positive 1 over 4. Take the reciprocal and take the opposite sign. And then I have my point 8,5, so that's going to be my x sub 1, y sub 1. So just like before, I'm going to put it in point slope form first because that's the information that I know, a point and a slope. So I have y minus 5 equals my slope of 1/4 times x minus 8. And then I'm supposed to be putting it into slope-intercept form, so I need to solve for y. So I do my distributive property. Y minus 5 equals 1/4 x minus 2. Add my 5 to both sides, and I get y equals 1/4 x plus 3. So y minus 4 plus 2/3 is perpendicular to y equals 1/4 x plus 3 because their slopes are negative reciprocals.